What if I told you that witnessing a black hole up close isn't just science fiction anymore, and it might happen during your lifetime? Forget everything you think you know about the impossibility of interstellar travel. Yes, we're still bound by the cosmic speed limit of light, making even a trip to our nearest stellar neighbor a multi-year odyssey. But here's where it gets controversial. Some brilliant minds are now saying we don't need to wait centuries for breakthrough propulsion technology. Instead, they're proposing something audacious, sending ultra-lightweight spacecraft to black holes using existing concepts. Consider this reality check. Our current rockets would take tens of thousands of years to reach even the closest star. However, revolutionary mission concepts like Project Starshot have already laid the groundwork for a game-changing approach. Picture this: a spacecraft weighing less than your smartphone, propelled by powerful laser beams hitting an ultra-thin solar sail, potentially reaching 20% of light speed. The target? Proxima Centauri, our sun's nearest stellar companion, reachable in roughly 25 years. But here's the part most people miss. If we're developing this incredible technology for exoplanet exploration, why limit ourselves to boring old planets? Enter Professor Cosimo Bambi from Fudan University in China, who's asking the question that's got the astrophysics community buzzing. His radical proposition: redirect this emerging nanocraft technology toward the universe's most extreme objects, black holes. And this is where the controversy really heats up. My idea is to try to stimulate the community about such a possibility. I don't know if it will work or not, of course, but it deserves to be tested. Professor Bambi explains. Sometimes people say, okay, this is impossible. And then after some decades, it's not. Think he's being overly optimistic? Consider these recent impossible achievements that skeptics once dismissed. Gravitational waves, which Einstein himself doubted we'd ever detect, were finally captured just a few years ago. The first photograph of a black hole, something that seemed like pure fantasy, became front-page news worldwide in the past decade. But wait, there's a massive catch that makes this mission even more challenging than reaching exoplanets. We don't actually know where our target is hiding. Here's the mind-bending reality. Statistical models suggest our galaxy should be teeming with stellar mass black holes, invisible cosmic vacuum cleaners, just drifting silently through space. Logic dictates that at least one should exist within 20 to 25 light-years of Earth. The problem? Unless these gravitational monsters are actively devouring matter and glowing with X-ray emissions, they remain completely invisible to our telescopes. This creates a frustrating cosmic hide-and-seek scenario. The Gaia Space Survey has identified our two closest known black holes, but they're disappointingly distant, 1,560 and 3,800 light-years away, respectively. At those distances, even our fastest proposed nanocraft would take millennia to arrive. Yet here's where the story gets exciting again. We might be on the verge of discovering much closer black holes. The complete Gaia dataset could be hiding nearby candidates we haven't spotted yet. Upcoming astronomical powerhouses like the Vera Rubin Observatory and the Kilometer Array might revolutionize our black hole census within the next few years. Imagine this scenario. We identify a black hole just 20 light-years away and launch a nanocraft capable of reaching 1/3 light speed. The journey time? A surprisingly manageable 60 to 80 years. Well within a human lifetime, though certainly a multi-generational scientific endeavor. This is not something we can do tomorrow. This is true. Unfortunately, this seems to be the trend for many experimental observations in particle physics and astrophysics, Professor Bambi acknowledges. The experiment will be the effort of a few generations of scientists. We don't do this just for us, but for future generations. But here's what critics might be missing. this isn't just about achieving the ultimate bragging rights in space exploration. A black hole mission would create the most extreme physics laboratory imaginable. While we've tested Einstein's general relativity using spacecraft around Jupiter and throughout our solar system, black holes represent the absolute limits of gravitational physics. Their intense space-time curvature would provide unprecedented opportunities to verify or potentially challenge our fundamental understanding of gravity and the universe itself. The implications are staggering. What if our current theories break down near these cosmic extremes? What if we discover new physics that revolutionizes our understanding of reality? So here's my question for you. Are we being too conservative by focusing solely on potentially habitable exoplanets when the universe's most fascinating objects might be within reach? Should humanity invest in this audacious black hole mission? Or are we better off playing it safe with conventional planetary exploration? This groundbreaking research has just been published in the prestigious journal iScience, and the scientific community is already debating its feasibility. The technology gaps are real, the distances are daunting, and the timeline spans generations. But isn't that exactly how humanity has always tackled its greatest challenges? What do you think? Is Professor Bambi a visionary pioneer or an overly optimistic dreamer? Share your thoughts. This could be the kind of bold scientific leap that defines our species' next chapter among the stars.